All right, welcome back. We're going to do a first order differential equation, linear, with actually being an initial value problem. Okay, so our equation is going to be, or is, cosine x dy dx plus y times sine of x equals 2x cosine squared of x. All right. First thing we're going to do is we're going to actually write it in the right form. Okay, we're going to write it in the correct form by taking that and dividing everything by cosine of x. Make sure I don't make a mistake like I did on the last problem, which luckily I caught before it went too far. So dy dx plus tangent of x times y equals 2x cosine x. So I divided by cosine x here. Okay. Now I'm going to find the integrating factor. Okay, so the integrating factor is going to be, of course, e to the integral of tan x dx. Okay, so the integral of tan x dx, that one should be pretty clear for everybody by now in their careers. Integral of, think of it as sine x over cosine x dx. Since sine is the negative derivative of cosine, this is going to be negative natural log of cosine x. Okay, so e to the negative natural log cosine x is e to the natural log of, let's write it as 1 over cosine x. So this is going to be actually 1 over cosine x, or rather secant x. Okay, so that's our integrating factor. We're going to multiply by that secant x on our equation. Okay, so multiplying the equation by secant x, we get secant x dy dx plus secant x tangent x times y equals, secant x, remember, is 1 over cosine. Okay, so now, since we already have only one cosine, we're just going to be left with 2x. Oh, that's awesome. Okay, now we're going to rewrite, we're just going to rewrite this as the derivative with respect to x of secant of x times y, okay, equals 2x. Okay, integrating this, we get secant xy equals x squared plus c. Okay, now solving for y, y of x equals, we can go ahead and just multiply both sides by cosine of x. So cosine of x, let's write it x squared cosine x, sorry, plus c cosine x. Okay, now we're going to go ahead, we need that initial condition. Oh, I forgot my initial condition. Pretend I had given you the initial condition from the beginning. Let's edit. Okay, so let's pretend I'd given you the initial condition from the beginning. y of pi over 4 equals negative 15 root 2 over 32 times pi squared. Okay, and let's copy that and bring it down. Okay, so there's our initial condition. So the initial condition doesn't necessarily have to be at 0 or 1. It's just at any point where we can fix one of the constants. Okay, so y of pi over 4 is negative 15 root 2 over 32 pi squared. So we're going to write in negative 15 root 2 over 32 pi squared equals pi over 4 squared cosine pi over 4 plus c times cosine pi over 4. Okay, so what is the cosine of pi over 4? No, it's not negative 1. That's right. The cosine of pi over 4 is the square root of 2 over 2. Okay, so we're going to get negative 15 root 2 over 32 pi squared equals pi squared over 16 times root 2 over 2 plus c times root 2 over 2. Okay, so let me move this over. Okay, honestly, this part is the hardest part of this problem for me. So negative 15 root 2 over 32 pi squared minus root 2 pi squared over 32 equals c times root 2 over 2. So negative 16 root 2 over 32 pi squared equals c times root 2 over 2. 16 over 32 is 1/2. So root 2 over 2 negative pi squared is c root 2 over 2. Oh, wow, c is just going to be negative pi squared. Okay, I'm running out of space, but I'm done. So c is negative pi squared. So going back up here, my y of x is going to be x squared minus pi squared times the cosine of x. Move it. My arrows were badly drawn. Okay. I could think of this as x squared plus c, right, times cosine x. All right. That's it for this lesson. I'll see you guys in the next video.